Welcome to RG classes, and today's topic is inertia and Newton's first law of motion. Today we will discuss first of all inertia. So let's start with inertia. Now we will start with definition. What is inertia? Inertia is the property of an object. It is the property of a body by virtue of which it resists any change in its state of rest or motion. That means it is the inherent property. It is the property that is contained in the object. It is the property possessed by the object, and due to virtue of this property, the object tends to be in a state of rest if it is, or if it is in motion, it will tends to be in a state of motion, and it will resist any change in state of rest or motion. So the inertia, if we write the definition of inertia, so what will be the definition? Property of an object by virtue of which it opposes. So we can write it property of an object by virtue of which it opposes any change in its state of rest or motion. So that is the definition of inertia, that is the inertia. So after inertia had been categorized into the two groups. So we are talking about the rest and motion. So on the basis of that, inertia has been classified into two groups. One is the inertia of rest, and the second one is the inertia of motion. And accordingly, this we will give the definition of the property of an object. For the inertia of rest, if we need to give the definition, if we need to give an explanation about the inertia of rest, so what will be the explanation? So the property of an object by virtue of which it opposes any change in its state of rest is said to be the inertia of rest. And in the same manner, motion, so inertia of motion. So the property of an object by virtue of which it opposes any change in its state of motion. So when opposes to change its state of rest, so that will be the inertia of rest. And when opposes motion, then it is said to be the inertia of motion. That means from this one we concluded that if an object is in rest, it will tends to be in a state of rest, or if in a state of motion, it will tends to be in a state of motion. So that is the property, and that property is completely called inertia, and on the basis of its state, it has been classified into two groups. Now we understood inertia. Now inertia and mass. Now we will understand the relation between the inertia and the mass. So inertia and mass are inertia is directly proportional to the mass of the object. That means more the inertia, more will be the mass. They are directly related to each other. So more the inertia, more the mass. That means we can understand it this by a simple example. Suppose we have a stone of this size, and we have another of this size. We have the two stones, a stone A, a stone B, or we have any two objects. So they are in a static position. If we tends to move, we will have to apply a little force. Why? Because mass of the object is less, so we will have to apply a little force in order to change its state of rest. But in this case, a huge force is required to change the state of rest of the object B. Why this happen? Both are the same object, both are made up of the same material, both have the same compositions. So why this required a little force and this required a huge force in order to bring any change in its state? Because mass of the object A is little, mass of the object B is much more than that of the object A, so it has the more inertia than the object A. Another example, suppose we have a bicycle and we have a truck loaded with. So in order to push a bicycle, it requires a little force. Little force, by applying a little force, a small force change can be brought in bicycle. But in order to move a heavy loaded truck, it requires heavy mass. Why it requires heavy mass? Because the mass of the object is huge, so inertia is huge. So inertia and mass are directly related to each other. So we can say inertia and mass are directly related to each other. And more the mass of the object, more will be the mass, more will be the inertia of the object. So mass and inertia are directly dependent on each other. Now, so we understood inertia of rest, mass means inertia of motion, inertia relation between the inertia and the mass of the object. Now Newton's first law of motion. First law of motion. First law of motion. So what is the first law of motion? So Newton's, from here the laws has been started. First law, then second law, then third law, and the law of gravitation. So the Newton's first law of motion states, if an object is in rest, it will be in rest, or if an object is in motion, it will be in motion until and unless an external agent is applied to change that state. What I am telling? If the object is in rest, it will be in rest forever, not for a while, not for an hour, not for a month. That means forever it will be in a state of rest. Or if it is in motion, it will be in a state of motion until and unless an external agent is applied on it to change that state. An external force is applied on it to change that state. So the first law, I am writing first law. If Newton's first law of motion, first law states that if an object is in rest, it will be in rest. It will be in rest. Or if in motion, it will be in motion. It will be in motion until and unless an external force is applied to change that state. External force, we can write external agent is applied on it to change that state. So that is the Newton's first law. Now from the first law of motion, so after this one we will do some examples, and after that the topic will get finished today. So from the Newton's first law of motion we get the definition of force. So from first law we get the definition of force. So what the Newton's second means, second part of the Newton's first law. First part states that if the object is in rest, it will be in rest, and if in motion, it will be in motion. That is the first part of the law. And the second part states that this state of rest and motion can be changed by applying an external agent. That means by the application of the external agent, a state of rest and the motion has been changed. That means this external agent is nothing but the force. Because what is the definition of force? Force is an external agent, force is a cause which when applied on an object, it changes or tries to change the state of rest or motion of an object. That means it changes the motion of an object. And here the same thing, here when the external force is applied, that external force is responsible for changing the state of rest and motion, and this work is done by the force. That means the external agent that we have applied, that is the nothing but the force. So the Newton's first law of motion give the definition of force. So from the Newton's first law of motion the definition of force has been derived. You can simply write from the second part of the Newton's first law of motion. It is stated that when an external agent is applied on an object, its state of rest and the motion can be changed, and this is the work performed by the force. That means the external agent that has been applied to bring about the change in the state of rest or motion, that is nothing but the force. So hence we get the definition of force from the Newton's first law of motion. Now some examples. The first law also gives some examples, such as first one, shaking the branches of tree. Branches of trees, the fruit fall down. So whenever the branches of trees are shaked, what happened? The branches at once come into set into the motion, but branches set into the motion, but what happened that means fruits tends to be in a state of means rest. That's why it क्या हो जाएगा, fall down. Again, whenever we move in a bus, whenever suppose करो bus is at rest, and whenever suddenly a bus start, we move backward, we lean backward. Why we lean backward? Because the lower part of the body which is in contact with the bus comes in a state of motion along with the bus, while the upper part that is not in direct contact with the bus tends to be in a state of rest, and so it lean backward. In the same manner, whenever moving bus, in a moving bus brake is applied, we move forward. Why? So when this happen, so this happen because whenever the force is applied on an object, so in the same manner, when the moving bus, same situation happen. Again, in the carpet, whenever carpet is beaten, dust fall down. This is because of the same Newton's first law of motions. So whenever suppose we have a carpet and it is beaten, so whenever a carpet is beaten, the dust particles on the carpet try to be the carpet set into the motion, but dust particle at that place will try to remain at the same place. So whenever it is beaten, the dust particle fall down, and there are many more examples, not only this one. So there are many more examples, so by which we can explain the first law of motion, and the answer of which can be explained only using the first law of motion. In the same thing, whenever in the game of carom, whenever it is a strike, so again same thing happen. So there are many other instances where we have some more instances, that is whenever a ball is thrown vertically upward by a person in a moving train, comes back to his hand because of the relative motions. And again we have the another example, whenever a running car stops suddenly, the passengers tend to lean forward. That is the same thing. Again we have the another example, when a corridor train suddenly starts, the sliding doors of the some compartment may open due to the inertia of rest and motion. So these all answers can be explained on the basis of inertia of rest and motion. Suppose again we are taking one more example. Suppose we have a glass and we are taking a cardboard on this and we are keeping a coin here. So whenever the cardboard are क्या हो जाएगा strike properly at a क्या हो जाएगा random motions, so the coil fall into the glass. Why this happen? Because of the cardboard set into the motion. At sudden the cardboard set into the motion, but the coin tried to be in a state of rest. That's why this happened. So Newton's first law of motion and these kinds of instances can be explained using the Newton's first law of motions. In next video we will explain Newton's second law of motion.